Hello, Replit community, and welcome to the spookiest night of the year, where it's clearly, definitely 100% lightning happening here, and we seem to have somebody from Anonymous on at the same time. Hello.
We are Legion. Expect us.
Well, with the spooky stuff done, Bram, let's. I'll put my lights back to normal, so I'm not freaking everyone out as we go. See, this is why it's fun to buy a nice lighting panel. Welcome to the spookiest night of the year, and on this night, Bram has decided to run his fantastic workshop on flowcharting. Now, we've given it a bit of a funny name, Bram, which you were a bit disapproving of, because the proper name is a bit more straightforward, isn't it? But I think whether it's got a funny name or not, you're in for some good stuff today. Before we get started, I do just want to remind everyone that we do have our tutorial jam on at the moment, with the deadline being this Saturday at midnight Pacific time. You have to build one tutorial REPL using our tutorial feature and teach something cool. Using the video pane is a good, but it must be one complete project or lesson. If you want to find more out about that, I'll pop the website address up on the screen in a moment. But the reason that might be of interest to you is because Bram is going to talk us through how to run a lesson using shared tutorials. Bram, I'll hand it over to you and we'll bring your screen up.
Well, howdy. For those of you who are watching this on recording, and for those of you in the studio with us now, I hope that you'll notice that I have a bell ringer, which is in teacher language, the thing that you have students do when they first go into the class to get their brains kind of moving. And there's a little link here. And if you actually use the chat link at the very top of our chat, you can go to this presentation yourself, or you can just enter this bit.ly URL wherever you are. If you're on a phone, you can do that too. And do your best with this. It's now 4:07, so we've already used up 7 minutes, or whatever time it is in your time zone. So I'll give you another 3. And if you click that, it's going to look like this.
So these bell ringer activities, Bram, for those that are tuning in because they're interested in the tutorial jam, for instance, these are things that we use in teaching to give people something to do when they get started, aren't they?
And also to get your head in the right frame of mind. I mean, when somebody walks into a webinar or into a big lecture, they're getting into a sort of passive mode. The drool's starting to come down the side of the mouth, or they're chatting with their friends. But if you actually have a bell ringer, people can activate their conceptual frame for things that are going on. And so I want people to get started thinking about these questions. And we'll even look at the answers that people gave.
Let's hope people are feeling brave enough to submit something then. I'll jump in there and pop something in as we go as well, while we have a look at that. So we've got questions on here like, what is an algorithm? What's abstraction?
I don't think that I'm asking them. I think I give them the definitions actually in the form.
Oh, it's a comprehension question. Yeah, I'm having a look now. Yeah. These are really nice questions because it's things like, what is a computer program? What's an essay outline? It gets you thinking about the concepts and a bit more, doesn't it?
Mm-hmm.
Ooh, the last one's got me stuck a little bit, Bram.
Well,
I've taught this for 20 years.
Terms are one that you don't know. All right. I'll just leave that open. I mean, I guess, most people are probably also thinking, well, why does this matter? Why are we talking about this? And that
will become clear.
That question we're about to answer. So if you're watching at home, I know that's been very boring for now. You could certainly have paused this and then come back in. But at exactly 4 minutes and 10 seconds on the timeline, you can re-engage.
I think what I'll do, I'll put the times of when we got back to it in the comments, and I'll put chapters in our watch again video then, hopefully.
Sounds good.
What we need is a nice visual representation of what's happening. Just an animated GIF of that cat typing. That's what we needed.
Well, okay, it's 4:10. So let's proceed, this is the way that this was advertised, Get with the Flow, collaborative flow charting, and we are talking about that. My focus is that if you want to teach computational thinking, which is a term of art among computer science teachers, it means a lot of different things, but we're going to go with code.org's use of Google's definition of it. If you want to do that, you really want a flow chart before you code. So let's take a look at what people's answers were. So we don't have that many people answering here. We got a bunch of people did very well. Is a computer program both a flowchart and abstraction? The reason why it's not both is that an abstraction is less detailed than you actually need. And a computer program is the thing that you need. It's like that's the territory. So it wouldn't be an abstraction, if that makes sense. The other thing here, I don't know why this person's got an 80. It looks like exactly the, a computer program is an algorithm. Okay, now back to our presentation. So today we've done our bell ringer. We're going to talk about computational thinking. We're going to give you an experiment to see what you do when it's time to code. And we're going to talk about what ABC means. We're going to look very briefly at abstraction with pseudocode, and I'm going to assume that everybody here knows how to do pseudocode, and I'll just like rush through that part. I'll talk about abstraction with flowcharting and some of the ways that I teach students to do it. We'll take an example of Monty Python's Cheese Shop, which is an analog or isomorph to the Guess My Number game. We'll talk about how you move from flowcharts into pseudocode, and I borrow a little Java docs style when I do that, and then how you move that into Replit, because we should be doing our pseudocode in Replit teams if we're teachers. And then at the very end, we'll look at how Mastermind and Wordle have exactly the same flowchart behind them. And I'll give you an exit ticket that you'll do on your own, and also a way for you to say, hey, we didn't finish your whole presentation, because you won't. We'd like to meet with you again, and I give you 4 options of when we'll meet again, and whichever one we have the most people filling in, that's when we'll do. And if you're watching this online after the performance, you can also fill out that exit ticket. I'm not going to look at this and make a decision until this weekend. So you have until November 4th to imagine that. Okay, here we go.
It's worth saying, Bram, we'll put the links to your follow-up sessions on the Community Hub on Replit. So if you go there, click on Community, click on the Community Hub button, you'll see when that event is taking place on there.
Excellent. So you're looking at a couple of my current students doing a flowchart for rock, paper, scissors, or Rochambeau, as some people call it. And I'm going to propose that what you're looking at is 2 students doing computational thinking. These are the 4 types of computational thinking that Google talks about. Breaking down the problem decomposition is very often talked about in terms of making functions, but it's also flowcharting. Pattern recognition, if I say that Wordle is like Mastermind, like that's a computational thinking quality, something that somebody who's able to do that is into. Abstraction, which is the map is not the territory, and if we hang out at the map, we can give directions better than if we are saying, well, walk by this blade of grass that's right in front of this bug that's right in front of your feet. And then how we design algorithms. And computational thinking is giving your students an opportunity to develop their own models rather than applying existing models. And there's always a tension when you're a teacher. The more you ask students to be creative, the more some of them will complain because school doesn't teach that. And so we have to get them out of their comfort zone. And what I've found myself doing sometimes, which I'm so sorry, Lord, is I've given them the pseudocode and asked them to code, which is just denying them any opportunity to think. It does give them an opportunity to demonstrate. Yes?
I think I'm very responsible as well for overly decomposing my instructions, which is pretty much the same thing.
Yeah, the concept in constructivism is whether or not students are sharing the cognitive burden, right? Figuring out what's going on. Generally, they want to sit back, have you figure out what's going on, lead them by the nose through stuff. And if you don't do that, they're very angry with you. But we want to encourage that. So there was this moment, for me, it was in my teenage years. I don't know where everybody else was, or maybe it hasn't happened to you yet, when you discover about diagramming systems. When all of a sudden, all the little lights in your brain start like well, you get the right side of your brain, the left side of your brain start like lighting up. Well, both sides of the brain start lighting up because it's both sides, right? It's, you know, what we know about stuff and then a way of abstracting it and modeling it. This book, Thinking in Systems by Donnell and Meadows, is most people's favorite intro to systems thinking. So if you haven't read it and you don't know what I mean by systems thinking, do yourself a favor and read this before you read your next science fiction book. And then on the right-hand side is a sort of dramatization of the discovery of systems thinking called Magister Ludi, Last Beat Game by Hermann Hesse. Now I'm going to give you guys a task. And again, you people at home, I'd like you to do the task as well, because we'll learn something from what happens when you do it. You'll see that there's another one of those little bit.lys. This is a program that is part of code.org's Computer Science Discoveries. And it's a very basic guessing game where you have, it comes up with a random number from 1 to 100, and you have to guess it, and you get only 5 tries. And so what I'd like you guys to do is go ahead and start. It's your task to code this. What do you do? Now, if you're an advanced programmer, you probably are not going to do any computational thinking because you've already figured out how to do this before I even gave you the task. But if you pretend that you're not, or if you're just a starting up coder, what would you do? So it's now 4:16. We're going to come back at 4:20. Maybe we could get some more of that Count Dracula music while we wait. If not, I'll go put it on myself.
I've got some background tunes in the settings, Bram. Okay. What do you fancy? A bit of lo-fi beats, or?
Sure. Anything Anonymous would like.
It's fair to say, Bram, that what you've got here is something that I would use to lead on to a lesson about a specific search algorithm. Is that sort of where you're going with this?
Well, it's an algorithm. This one isn't going to be a search algorithm, but yeah.
In the 100 days, we have a game that we build, which is higher or lower guessing game between 1 and a million. And the reason we do that is because I like to, in my classroom teaching, I like to jump into teaching about binary search with that. So it's like a nice, realistic jumping off point from that there.
Well, that would be interesting if you were designing some kind of an AI, right? To do it. But okay, yeah, designing a binary search algorithm. But that's great, right? So you're not actually there you're not guessing the things yourself. You're letting your algorithm do it. Oh, I love it. I know that people feel like they're not getting their money's worth because they're having to wait for these little periods. This is our last wait time in the video, first of all. And second, I've actually given you the whole presentation in the chat. And it's available from the live stream. So you're getting more than your money's worth because we're probably going to make it about halfway through this tonight. And that's why we have that last slide with the exit ticket, where you also get to tell me when you want to reconvene and do the other half of this. This idea of bell ringers and exit tickets is something they teach us in school. Personally, I don't like being too structured and having to follow everybody else's map every day. But just in case my principal might be watching, I want to pretend that I always start with bell ringers and with exit tickets.
We definitely always do it, don't we, Bram? Always do it.
Because it could be one of those random observations, when she comes in. Hey, where was the bell ringer? Oh, this is the one day I didn't do it.
I think it's fair to say, though, that classroom teachers, we tend to start our careers out with a prescribed set of what we want to do. Then you get in the flow of, well, actually, it doesn't really link well to this lesson. So students are very good at spotting when you're just following a pattern or wasting their time. So I think that's why we tend to avoid it sometimes.
Yeah, it's jazz. It's not classical.
Absolutely.
Got to be some improv. And yet, I've had students go, I don't like this class. It's not predictable enough. I like, Miss Fitzgerald's class where we just walk in and, she gives us the candies and we do it right. And, we know exactly what we're supposed to do. And I go, yeah, kind of like Pavlovian apparent conditioning, right? And they're like, what's that? And I go, well, you know what that is. That's what Facebook and, Twitter and Instagram make you do. Okay, I think about a minute left. All right, there we go. So I don't know what you guys did. And if anybody who's in the chat would like to say, how did you begin? Did you just start writing code, or did you do anything else? Did anybody do any pseudo coding or flowcharting, or just sitting back and thinking and imagining in their mind? Well, when I run this lesson with my kids, almost 201, they start coding. And then they get caught up in the question of, oh, did I code the random number generator properly? Or, maybe I didn't put the right quotation mark in or whatever. And so, actually 5 minutes isn't enough time for them to do this, because they're still working out their syntax. Because this is like one of the first things that you give a kid to do. It's not like, 2 months in, they're making a program like this. And the ones that you very rarely find who go into flowcharting or pseudocode first are way very much ahead, because they're not being caught up on these little details. So I call just going in and starting coding, I call that commando mode, and use that term with my kids. So the commando creed is, I made this really lovely animation, but it's backwards. So I'm going to have to just read the white part to you. Is that first to understand, first to adapt and respond, and first to overcome. That's what the commando says they are. And they react instantly, and they have trained instincts. So you wrote MB Tech Media. I don't know what that is. Oh, some new person. They notice all the important things, and they focus on the goal, ignoring distractions. So you can imagine when you drop a commando into a situation, that's what they do. And that's why they're very special. And a commando coder, if you could imagine a commando who's a coder, they don't have to think about syntax. They're fluent. It just comes right out of their fingers. They imagine the whole program, the whole shape of it. They don't have to, they don't have to flowchart it or anything else. And they experience flow. They don't, nothing stresses them. There are no distractions. They're just doing it. Like you could, break a glass next to them and they wouldn't even notice it. And if we look at the Cisengali, I think that's how his name is pronounced, who is the scientist of flow. He says that you get into a flow state when you have high challenge and high ability, right? If you have high ability and low challenge, then you're bored. But high challenge and high ability, that's what a commando is all about. And it would be nice if you could just have that all the time. And so that's all you would ever do. That's the flow. But if you're not a commando, here's what happens to you if you try to do commando mode. You have high challenge, but low ability. And that means you get into anxiety. You're stressed, you're alert, but you're stressed. And what happens when you have stress when you're trying to code? I'm going to slow down and give you an opportunity to try to remember the last time you felt stressed when you were trying to code. If you're somebody in business, you probably remember that there was a deadline and something wasn't working and you didn't know why. And you discover much later that it was a very simple thing. You just weren't looking at the production version of whatever silly error you were making that you didn't notice because you were so stressed out. Now, here's a very complicated diagram. It's a cognitive load theory, straight cognitivism. And the long-term memory stuff is the stuff you've already mastered. It's already in there. You don't have to think about it to do it. Then those camel-colored circles are the number of things you can hold at one time. And if you're a commando, you're dropping a whole lot of stuff out of the environment and you're just focusing on the stuff that you're just focusing on. If the blue things are the stuff that you're, the task that you're being given and how complicated that task is. And if you put all that stuff together and you add your working memory, your capacity for holding on to things, you can see why it matters how complicated you give yourself a task to do. So if I have a lot of distractions, like if I have an IDE that's really, really complicated, or if I'm under a deadline, I have cognitive load that gets me past my ability to think well, right? So we don't want that. We want to make things a little simpler if we possibly can, so we think better. I'm going to just play this. I don't know if this is going to, are we going to hear it if I play it, David?
I'm not sure. It depends if we've got it shared or not. We can give it a go.
Hey kids, welcome to a lesson.
Yes, no.
If, else, if, and conditional.
Sort of. We're good.
Yep. And this
So this is an example of code.org. I love code.org, but this IDE is insanely busy. So it's an incredible lot of cognitive load just to try to deal with it. They're trying to let you know, oh, you could do it in block coding, or you could do it in text coding. And then there's all this stuff, and we've got all these things mixed up and everything else. But if you can imagine this teacher, the teacher is coding in front of you and explaining what he's doing while he codes in front of you. And of course I've done that. Of course you've done that. And to kids, that sounds like this. Wow, 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 wow. If you remember Charlie Brown, that's what that sounds like. So how do we get out of that problem? Well, I think that what I call Simon Says, which is you're watching me coding, is high cognitive load. The kid doesn't know if they've heard you properly. They're having to keep up with you. Maybe they miskeyed something and now they're worried about that. It doesn't work. They don't know why. And so one never really wants to just get in front of kids and then have them code while we're coding, thinking that we're doing anything for them, because it creates, as I said, stress for them.
We're saying at this point, Bram, that the idea of high cognitive load is basically where you have an amount of cognition that you can process at any one time. If you're on high cognitive load, you haven't got that excess capacity to think or reason out of problems. So we want to avoid that as much as possible when we're teaching something.
Right. We want to take that out, which is like the more I give students, the more I'm defining the task as a complicated one. So even if they aren't worried about it or stressed about it or not really smart about it, still I'm making it hard for them just by giving them too complicated a task. Mm-hmm. So fear is the mind killer. You can't think well when you're stressed, unless some people can. So I'm going to say that before creating that kind of stress, you can remove the number of things that you have to hold in your mind at one time. If I'm just a beginning coder, I don't have that fluency at like where to find the curly bracket on my keyboard. So maybe I could not worry about all that syntax and all that coding and just focus on what are the steps I'm going to do in what order. And that cuts down what's called the intrinsic load. So the extrinsic load is the stuff that, like, okay, they gave you a complicated IDE, they're asking you to listen to them while they write, all that kind of hard stuff. But the intrinsic code is how many things do I actually need to do at once? And I can cut that down if I use abstraction before coding, ABC. So remember ABC. It's the same thing as outlining, which somebody mentioned before in the chat. If you always sit down and start writing an essay, the amount of time it takes you to write a good one is much more longer because you're writing a paragraph and then deleting it and this and that and the other thing. And only an English teacher, you know, or somebody who's done a lot of writing knows this. Getting to an outline, once you get yourself to that stage, afterwards your essay gets really tight because you know why each paragraph exists and how are you going to transition from one to the next using a transition word or, you know, keywords and all that kind of stuff. So outline is great and flowcharting is great. Now, I'm going to talk very briefly about pseudocode, which is decomposing into functions. You don't think about the whole program. You think about all the different little pieces of the program.
Can I interrupt you for just a second? Because I just want to say something to you about pseudocode. In the UK, our exam boards dictate the syntax of the pseudocode. And I always think that's really horrible because the point of pseudocode is it looks a little bit like code and you can just write things in more plain English, can't you? So for all our UK viewers, we feel your pain, or I certainly do, don't worry.
Yeah. One of the problems with pseudocode is code drift, where the more you already know you're going to do it in a particular language, the more your pseudocode looks like that language. Mm-hmm. And if you're just writing pseudocode for yourself, who cares, right? But you're starting to increase your cognitive load when you do that. So pseudocode is easy to start with. You're just trying to say, what's the method I'm trying to do? You code the syntax later. It's low stress. You don't care about it being perfect. And of course, it's high stress if they're testing you on it, which is bad. Works for any language. It's not formal. There are no rules for how to do it, although there are conventions that teachers teach their kids, which I will show some of mine. Easy to do, easy to share, and it's collaborative because different people can be pseudocoding together, it doesn't break what I'm doing to have you pseudocoding on the same document that I'm doing if you're pseudocoding a different function in that document. So I like to do katas if you are looking at this slide and you, yeah, I'd like a cough button. Do we have any cough buttons here?
No, I've just got a fancy setup. Sorry,
yeah,
Bram.
I taught 6th graders today, so that's going to weigh on the old glottis. If you click this thing, this leads to how I do katas, which is like pair coding with a gatekeeper and a keymaster. This is what I'm going to show you is the pseudocode for this simple little this is like the first program that I teach the kids to do. So first I give them a description of what the thing is going to be, and then I give them code comments, and their task is to write the code underneath the comments. And so this is what it looks like with the code written underneath the comments. Now you notice that I'm being purposely vague. I'm not saying declare a string variable. I'm saying make it. I don't say named color. I say for color. I don't say equals. I say set it to. And this is like, I'm doing it because I don't want to give them the syntax words to use. But by doing so, I'm actually making it a little bit harder on purpose, which feels a little disingenuous. Like, why not just be helpful? Then we just remove. So you see, this is what it looks like with the pseudocode and the code. And then at the end, when it's working, right, because none of these comments are going to affect the execution, you can remove all the comments. You have just the code. And this code is much easier to read. Right, when you look over here, it's like, whoa. But this, I can see what that is. And I can copy this into my done file. So, to talk Replit for a second, if you got your index.js file, or your script.js file, let's say, I don't know which one we are, probably script.js. I've got this to start them off with, and they start coding. And then when they finish their coding and they delete all this stuff, they put it in done.js, and then they copy my template back into script so they can write the same code again, faster and faster and faster. It's fluency development. Mm-hmm. But anyway, I don't want to go too deeply into that here. So the problem with the, cough button, problem if I give them the pseudocode is that I'm squashing their design process. They're not getting an opportunity. I'm protecting them from stress. They're just translating words into code. It's not computational thinking. It's just coding. So there is another way, of course. And this is what a flowchart looks like the way I do it. So if I was to do the simple guess a number 1 to 100, we set our guess equal to 0. Why do we set our guess equal to 0? When we declare it, because we're going to be changing it here over and over again, and we don't want to be declaring it over and over inside a loop. You'll notice that my variables are in bold. You'll notice that here I'm writing not equal to, but if it was equal to, I wouldn't put 2 equal signs in here. I'm not going to say you're wrong if you do, but I'm trying to get people away from the idea that this is code inside boxes. It's the simplest possible things you can write in to signify what you're going to go and do. Any of my students could look at this and read it in a second because they've learned how to read flowcharts. If you don't have practice doing that, it may be harder to get what's going on here. These are if you use Lucidchart, which I'm going to talk about today, these are the words that it uses for these shapes, which are the things that define what a flowchart looks like. And I have to sometimes say, well, go find the diamond, right? I have to come up with a word for the shape to point to it. And kids find it interesting that the pill shape is a stadium. Like that's where that name stadium actually comes from, is that's the shape of stadiums. And so I talk about a little bit here, like what these things are for. And you have access to this document. If you look at my slideshow, there's a link for it at the end. So my conventions, I think I just said that, for a prompt, we have 2 shapes. We have the display, and then we have the variable that the user does the manual input in. Simplify the words, put the variable references in boldface, let the symbols talk. So I don't have to write input guess here. It's an input shape. So I just write guess. Again, that's how flowcharts can be easier to read visually. Never cross connectors, always reorganize the flowchart so that never happens. It just give yourself the knowledge it is possible to do. And align the rows and columns. So if you look at the bottom here, all those diamonds are aligned vertically, and they're also aligned horizontally. It's like they call them swim lanes in certain kinds of diagrams. Mm-hmm. And if we look at this one, there's a design flaw. So in chat, when does the output from this program lie?
Whilst we wait for the answer, Bram.
Yes, I'm going to wait
One
for
of the
the
things
answer.
whilst we wait, I just thought I'd give you a little anecdote about my program design. I love flowcharts. I keep a little notebook with me at all times, and what I'm normally doing is flowcharting ideas for programs. I don't often get the chance to build everything, but there's lots in there. But what that does is it shows the students that they aren't just for beginners. They are to sort of break down a complicated process. So, I think when you model things like that, that works quite well as well, doesn't it? To show them that it is actually a worthwhile skill to have.
Right. And at this level of flowcharting, I'm actually flowcharting almost line by line. But at a higher level, you're flowcharting what the different functions are doing. So you might not flowchart at this level. So I'm not getting anybody in the chat saying that they know why this output lies. So I'm going to throw it over to you, David.
Oh, God, I have to have a look at it then. Right, let's have a look. So 47, guess a number. Guess the answer, yes, you got it. No, too high. I'm not entirely sure. I mean, is there something in the fact that it's not repeating or going back to guess the number again, or is it just a
That's
one-stop shop?
the answer to my next slide.
Okay, I'm a step ahead.
So
I feel good about that.
Slide,
I don't know what the answer to this one is.
I'll give you a hint. They were trying to cut down on processing, for the computer. They want to make it easier on the computer. But as a result, the computer ends up lying to you. Supposing I'm playing this game, right, and I put in a cue to quit. What's it going to say?
It's going to crash, presumably.
No, it's going to say too low.
Oh, because it's reading the number as it says,
is it equal to? You got it. No, it's not. Is it greater than? No, it's not. Well, then I'm going to say too low. So no matter what I do, if it's not too high and it's not equal, it's going to be too low. No matter what I type in, that's a lie, right? That's not a validated answer. So that's a problem with this flowchart. The kids get this. This question is not one that really throws them. And then this doesn't throw them. Like you said, if you only get one guess, all that feedback all that incredible effort that I've put into giving them feedback, like too high or too low, is useless because they can't do anything afterwards. So we have to make this into a loop. After I give the students this flowchart, they look at that and they get that. They're already into design thinking and they're learning to read flowcharts at the same time. And now they want to say, well, what should we do instead? So I might say, well, how would you fix this? Go flowchart this. How would you fix this? That's hard for them if I haven't taught them what loops are yet. But this is what the loop looks like, right? And you can look at this loop and kind of see how that would work. What's interesting is that there's almost always more display shapes than there are decision shapes. So on a test, I might say, how many decisions does this make? And they might look over here and say 4, and they learn to say, oh, it's only 3. Okay, so I'd like to just explain about pattern recognition. Somebody is saying BDD. Yeah, I can't answer all these questions at the same time. When my question comes up with something,
I'm keeping them together. Don't worry, Bram.
Okay,
at the end. And Buddy, don't worry. I'll make sure that I'll send you a link or something on Discord later. Okay.
So having a picture of the shape of a program allows you to recognize when there's a pattern. And I'm going to just go into this sketch by Monty Python, somewhat in the middle, but here we go.
Yes, certainly, sir. What would you like? Well, how about a little red Leicester? I'm afraid we're fresh out of red Leicester. Never mind. How are you on Tilsit? Never at the end of the week, sir. Always get it fresh first thing on Monday. Tish, tish. No matter. Well, 4 ounces of coffee then, if you please, stout yeoman. Ah, well, it's been on order for 2 weeks, sir. I was expecting it this morning.
I think you get the idea. In this sketch, and I have the dialogue here for people who want to actually code it perfectly, he doesn't have any cheese. But in our version of this program, he does have 1 cheese in stock, and you have to guess what it is. And I actually found someone online who had made a full list of all of the cheeses that are mentioned in this sketch. And there are quite a few. And they're in different languages. So I asked the students, well, how is this similar to guess? And they'll get it. They'll think, oh, yeah, there's the 1 cheese that you're trying to guess. And, you're keeping on guessing. And the only difference here is we don't get a higher or lower. Instead, we either get a no or we get some kind of funny response. So by the way, SWBAT stands for students will be able to. And so the first thing we want students to be able to do is read a flowchart. Again, we give them this and we give them this, and I ask them, how is cheese shop like guess? Maybe they'll be able to get that, but at least they're putting some open-ended divergent thinking at the task. Here's what cheese shop looks like. Now you see how these are different, right? One of them is vertically organized and one is horizontally organized. So I might display one of them on one monitor and one on the other, or have them, looking at two or going back and forth until they start seeing, well, even though they're kind of differently organized, they're the same program. Same number of shapes, just different things written in those shapes. Now the next SWBAT is, can you edit a lucid flowchart? So I hope the people who are here have opened Lucidchart and created their first flowchart, or at least seen that they could. And if you're doing this along at home, this would be a good time to pause this presentation and go to Lucid. And I gave instructions. The place to get there is lucidchart.com/pages. I'll just put this in the chat. That's the way to get straight to the place where you can go and create an account without dealing with a whole lot of other stuff. And this is how I do it. Like, I'll have the flowchart up on the screen, and I'll say, well, how could we make it so that you don't have that lie, right? That lie where no matter what I write, it says too low. Students would say, well, you could say, if the guess is too low, do this. And I'd say, okay, well, what would you put? What symbol would you use for that? And let me see, a diamond. Yeah, that sounds good. And what should I write in that symbol? Guess is less than answer. Good, that's what we want to put there. And then what other next? So you just go through this dialogue, and everybody's made a copy of the flowchart. So as I'm doing what the student tells me to do, I'm showing how it's done, and I'm showing a good version for students to model. To model for the students, and then they're doing it on theirs. And at the very end of that lesson, right, because I'm talking now as a teacher, how do I teach this, right? At the end of that lesson, I have all the students submit their flowcharts to me. They can do it by exporting a ping, or if we're using Lucid in the educational team version, I can access all their things nicely. And this way I can see, were they able to do this or not? Because I don't want to move. I want to make sure that my students are able to manipulate this program. Mm-hmm. So then what happens?
I'm going to ask you a quick question here, sorry. One of the things that we do in our exam board in the UK insist upon us doing is being able to manually run some data in the flowcharts. They call it erroneously trace testing, but it's a common thing that we do in the UK. Is that something you get your students to do at all? Follow along with the flowchart and work out what the output would be?
I don't always do that. I usually do it verbally. But it's quite possible to have them, do exactly that thing, make a table and run everything through. I tend to do it verbally. Like I'll go point to a symbol and say, now what happens? Now what happens? Like I'll use my pointer on the screen.
Yeah.
Okay. Now here I might say, well, I want you to come and join my flowchart. Now this would actually work if you guys did it. If you went to lucid.app/join and then use this join ID, right? You'd be able to get a copy of this, which is a teaching chart in Lucidchart. One of the nice things about Lucidcharts is that they have all these pages at the bottom, which is very, very handy, right? And another nice thing is that it has, if you buy the team version, or if you try the team version, it has the ability to do comments. So if I want to make a note that say I have to declare this variable here, I could say insert comment and say declare this here. Right. And then if you're looking at a flow chart, you see, oh, there's a comment. I can go click on that. I can hide the comments later. That's something that not a lot of the places do, other programs that do flow charts. And I can share it to give people the ability to collaborate with it. I can share it with giving the people to just, make a copy of it. All nice things that we can do with Lucidchart. So they've joined it. And now I ask them to go and place, label, and connect the symbol. On the common flowchart. Now, I only do this if I can trust the kids to not immediately start, making things all over the place. So if they're 6th graders, I probably don't do this one. But if they're, 10th graders or 11th graders, I might do this one. Then this is my favorite one. And this duplicates the way Replit likes to work, where you actually make small teams each team makes a copy of the master flow chart that isn't completely finished. And then we ask them, well, now code a function to validate this, or code a function to make an average of how long it took you to guess over a number of different games. Whatever it is that we ask them to do, each of the teams goes and does that. Or maybe I ask the teams, come up with an improvement on this game and go and code that. And then each team can submit theirs. So this is the most computational thinking friendly of all, because it's not as teacher directed and it's giving students an opportunity to be creative. Yes, David? Okay.
I'm just nodding, Bram. I'm just nodding. Don't worry.
So the third thing is, can they design a flowchart from scratch? Again, like start charting new functions is a way to do it. I would have them start pseudo coding after I feel like we've extracted all the value we can from the flowcharting phase. And then we go to the pseudo code. And I've just written what the steps are that I follow as a teacher. I don't need to go too deeply into that right now with everybody, since they can see this and have a copy of the presentation. Separate pages for each function. That's a handy thing. So I actually name these pages at the bottom by the function that they are. And so here we're looking at main, and main calls these different functions. In this case, I use this symbol for a function. Other times I use the upside down house as a symbol. That's a link. So if you click on that, you go straight to the page where that function is, which is handy, but then you're having to monkey around with how do I edit it? Because whenever I try to edit it, I click on it, it goes to another page. It's a little annoying. So I'm back and forth as to what I'm going to standardize on for functions.
If it helps, Bram, the box with the extra lines in is what we use in the UK. The exam boards use as the standard subroutine symbol.
Oh, really? And I made that up myself, and I was right. You see, that's what it looks like written in the matrix. All right, awesome. Now I'm going to keep that. Okay, since you've given me that, I'm keeping that. And each individual function can start looking somewhat dicey, and you can use spaces to do stuff like data modeling and things like that. So this is a mastermind how you analyze a guess function. Okay, so the fourth thing is, can they code from a flowchart? And I'm going to just briefly show how that works. So here's our flowchart. The first thing I do is I say, okay, what are the different stages going on here? Does this one tell me that? No, this isn't a match at all. Sorry, that's a bad sign. But you do have to set up some globals, right? And so those are kind of outside some of the other stuff. You do have to start your loop. You have to get a single guess. And you can see that it's two shapes for a prompt statement. You have to generate your response. So by showing the students these different pieces, that again helps them start making a translation from what are they seeing to what are they going to do. While we're talking through it, I may come up with some design questions and put this in. This is what, in terms of Replit, I'm designing the thing I'm going to put into the project, right? They're going to go and when they get a copy, it's going to already have these things. And so then we start the pseudocoding. And so what are the things they have to do? Split it into functions. This is a Java style where you have two asterisks if it's actually a function name.
Bram, is that something you give them in advance? Because we had a question on Replit 101 last week, which is our live coding helpline, which is, how do you decide what becomes a subroutine? And my answer was really experience and looking for things that can be reused. But at this point, when you're teaching it, do you tell them, I want this subroutine, I want this function? Is that something that you...
What I do is we're looking at the flowchart. Oh, we're looking at the flowchart. Is it starting to get very complicated over there? Probably a good idea to move it over to a new page and then make a link to it. So it's a very visual process to pull the thing out and then get it more expanded.
That's great.
And this is the Java style. And if you could imagine giving students this and saying, okay, go code from here, right? There's something kind of elegant about this. They have to decide how they're going to do the choose reply function, but we know that it's returning a reply based on the flowchart. And this is the stub of it. Like we don't know what really is going to happen, but this function could be inside a lot of other functions and still allow the rest of the thing to work until they actually make it happen. But I like to use this Java style of saying, are there any parameters, any arguments that come in? Is anything returned? And this is where the kids, like, who's actually in charge of making this particular function? Coding under the pseudocode again. And that's the way the cheese shop works if you compare it to Guess. Last thing I want to leave you guys with is, look, we managed to do it in all the time we had anyway. I guess I probably thought I would go slower. So this is Mastermind, the version that I coded. I have a student coding his right now, and it looks entirely different. And some of his design decisions are different, but it's kind of similar. And this is Wordle. And as you can see, I managed to grab Wordle before they made it unavailable and make my own Replit of it. So you can see both of these, you can get Replit. And it turns out that Wordle and Mastermind are exactly the same. They're both they'll both analyze in the same way. So as soon as my student finishes his version of Mastermind, which he's working on right now as we speak, he's going to go and convert it to Wordle and see how fun that is. So here's the Mastermind flowchart. Watch what happens when I change it into Wordle. Dunk. Mastermind Wordle.
Exactly. That's amazing.
Same. Exactly the same.
That is really amazing. That is absolutely the same, isn't it?
Yeah. Again, this is just
I never really thought about that before. It's interesting, isn't it? Because I think I posted a link to Mastermind in the chat because I know that when I've talked about it with my students, I get a lot of blank looks of people that don't really know what it is. Whereas if I mention Wordle, you get complete recognition almost straight away, don't you? So it's another opportunity to bring in things that are a bit more relevant to your students and show them something amazing like this, where it's literally the same structure.
And the other thing is, I actually position Mastermind as developing coding mind. Because Mastermind, to make the hypothesis, to track it through and see, well, why did it end up like this instead of what I was thinking? That's debugging, right? So if you're good at Mastermind, you're going to be a good coder. I stand by that. And if I can train a student who's has a hard time with Mastermind to get good at it, I say, so you can learn this stuff. Mastermind is awesome. I love Mastermind.
I like that because the common thing is chess makes you good at computer science. I don't believe that they overlap massively, but I can 100% see your point with Mastermind and Wordle. It is a better problem solving analogy, I think.
And I actually think Mastermind is much better than Wordle for teaching programming. Because Wordle is much more like finding and seeking, possibilities. Whereas Mastermind, you actually have a very, very structured kind of thinking required to get it in 7. Okay, so here's the exit ticket. We're going to see how much you understood from today. You're not going to be able to click on this unless you have access to the slideshow. So again, I'm going to put the slideshow into the chat for people who didn't go to the very top of the chat to find it. And just take a moment on that. When you go into that exit ticket, what you're going to see at the very top is this question of, when do you want the follow-up session? So again, if people would like to hear more, they can. But you know what? Since we actually made it all the way through, I may not do a follow-up session. I think this is enough. I thought I'd go slower and I didn't. So maybe no follow-up session.
What we could always do is collect together some questions async, and maybe you could do a video for us to answer anything that's really a standout. That might work better than having to do in the live session.
Okay, so we will do a follow-up session. We will do a follow-up session if people ask for it, and the way that you ask for it is to fill this out. But then it's the exit ticket, and we can see how people are responding to this exit ticket. Oh, don't look at that. That's the answer. Oops. Okay, and that's it. And here's me. Right. And if you see the last page of the slideshow, we have some links to some handy things.
Bram, thank you for that so much. I'm going to bring up a few questions now, if that's all right, that we've had as we were going. I'll bring up some of the Buddy's question from earlier is not massively linked to flowcharting particularly, but I think it does cover a few of the programming things that we want to look at. So I'll bring that up first. But his question was,
I'll return to my anonymous desires.
Shall I put my lightning back on? That's what I need to do. There you go. No, that's just distracting, isn't it? That's just distracting. I'll put it back to normal. So Buddy says that he doesn't have a problem getting started, but what he does struggle with is losing motivation as he's going. Do you have any top tips for how to keep him engaged with the project once he's in it?
As a teacher or as a student?
Well, as a student, I would have, as a focus as a student, but certainly what strategies do you use as a teacher to keep somebody, engaged in a project that might not be the most exciting to them?
By the way, yes, Trey, we'll absolutely do that. that was, that was one of the things that would have made this longer, and we will do that if we do the follow-up.
I'll just pop that on the screen so anybody watching can see what Trey said, asking for a live lab.
Yeah. I don't know how to respond to that. I mean, if it was a teacher asking that question, that might be a different question. But as a student, I think finding a way to make it yours, but
make it personal, make it.
Here's the thing, right? All this stuff feeds on self-efficacy. It feeds on feeling that you can do it. Mm-hmm. And if you're hacking away at it and you're not able to make it work, I think you could lose motivation pretty fast. But if you're able to make it work and then go, how can I make this better? Here, one of the things is trying to make elegant code, right? That's the term of art, which says as few lines as possible without it being parsable. Parsable, right? Parsable means when I read the code, it makes sense to me. Whereas there are some people who do like code that's like very, very few lines, and it looks like regex, right? Like regex is impossible to maybe
too clever for its own good code, we call it.
I can't read regex. So we want it to, both look good and have as few lines as possible. I'm doing code high school with some of my students, and I give them a problem like, make these 9 boxes. And then I say, well, you're going to get an A if you can do this in 30 lines of code, and you're going to get a B if you can do it in 40 lines of code. And it causes them to okay, I made the 9 boxes. Now, how can I optimize it and make it in fewer and fewer by more use of functions?
One of the things I think that works, and that's absolutely right. One of the things I was going to say to this is that I find that students often lose motivation if they've got an idea for what they want, but they haven't. The idea is getting too much to keep inside your head. And I'm not saying that in any negative way. That's what cognitive load is. You're trying to keep this enormous patchwork of ideas you've got in one person's head. There's a reason big software is developed by teams of people. So that's where things like flowcharting come in really helpful, because you can get that out of your head onto paper or onto Lucidchart. And then when you come to build it, it's a much more straightforward exercise of working out how to execute individual parts or individual steps. So if you are getting lost in the mires of your project and then losing interest in it, try flowcharting, try planning out in advance. It feels like a waste of time, but it really is not.
So to be even more specific about it, the decomposition saying, well, I may not be able to code this whole program, but I can code this piece, this subroutine, this method, this function, right? Let me just code that. Right now, what's another low-hanging fruit one that I could go? Well, I can code that one. Everything else is a stub. I think it's important to know how to do stubs so that you can at least see the thing working in some form.
I will do a bit of a plug for Ghostwriter, which is our new AI programming tool that was released today. If you can summarize what you want to build, Ghostwriter is pretty good at giving you the code to build it. And honestly, again, this isn't the big product pitch. It just so happens it meets in with this particular point. But I was doing a side project last Saturday. I planned it to run about 3 days with Ghostwriter because I'd already flowcharted it and I knew what the things I wanted to build were in my head. I did it in an afternoon instead. So it does speed up your skills. And if you can do that decomposition and you can turn it into an idea, a smaller concept for each stage, Ghostwriter comes in really, really helpful, and other AI tools would as well. Right, the other things, Trey is a big fan of yours. I just want to bring up this comment because I think this was lovely. It was the idea of teaching to mastery and not to time and not leaving students behind. Great job there. So Trey's a big fan. And one thing he's asked, though, will this be on the curriculum hub? Now, we haven't got anything planned, but that might be an idea, Bram. This sort of like a little course on flowcharting to code might be a nice little stub. Maybe we can get some of the reps read EU together and build something on it. Well, I'm not going to sign you up for anything in advance.
If we do that follow-up session and it's recorded, then that's exactly what that would be. In.
Absolutely. So we'll give that a go. And Dawn, who's come to a few of our live sessions recently, says she's still learning about the features. So she's still learning about the features. If it were replitized in terms of UI and design, it would be quite compelling. Well, the one thing I will mention on Replit, in any REPL, if you make a file called .draw, you get a shared whiteboard. And if you're using that in Teams, you can use that for simplistic flow charting, but you can do it quickly and dirtily inside a REPL and keep everything together. Now, we probably need to look at upgrading that functionality to support a bit more, like flowcharts and stuff like that. But that would be nice then to keep it all in one place. But you have a lot of success with Lucidchart, don't you, Bram, and getting the students to share and work together on it.
You know, if you saw that first slide where they were on the whiteboard, the problem with that is, you know, now the girl's finished her code. She's made her rock, paper, scissors. And now we're moving it from procedural, meaning it's all done in pop-up alerts and prompts, to being a web app, right? Well, that flowchart's going to hell, right? Because you can't, let's Halloween. You know, you can't.
It's Halloween, it's fine.
A lot of this stuff isn't going to work anymore. Well, is she going to go and like start editing the flowchart on the wall, right? The flowchart isn't in Lucidchart, so there's really nothing that makes her want to go into Lucidchart and make the new version of it. But if you start having it in Lucidchart, you can then have the version of the old version, the new version, edit it, have it saved, bring it to other students. And just in general, it's so much easier to write and to read. Think of Lucidchart as your, what's the name of the new Replit code helper? I forgot the name of it.
Ghostwriter.
Yeah, it's like Ghostwriter for flowcharting. The symbols are right there. You just drag them in, boom, 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 boom. So I'd advise against that. I find that whenever I come up to people using an interactive whiteboard where like trying to make something that looks like anything is almost impossible, you know, you're taking away the joy of a tool. You're using the wrong tool for the job. Lucidchart is free for 3 symbols. And after that, you know, you need more. So that's why we go and spend the $9 per student to get the team license. And you can reallocate. So if you have, you know, 25 students every quarter, you can take the names off and put a new set of names on afterwards. But it's just, I love it.
I think when I've used it, Bram, we've never paid for it. We've just got them to make a little box around the flowchart they've just done, and you know, all do it on one diagram. Which is, I know it's a bit, we're working around the problem, but for lower level coding, it does work. So bring this up as well, because
with the free version, you can't make more than a certain number of symbols. You try to make one more.
Oh, I didn't realize there was a limit. I thought it was the amount of individual. Oh well,
it's
that's
both.
Interesting.
It's
both. Oh, okay. So I just want to bring this up because Dawn has also said that one of the things that's interesting when she gets stuck on something is move on to something different. She says when she's stuck with code, she picks up a soldering iron, and that's a good strategy. Actually, it's why I spend so much of my time walking around the school, because if you're stuck with code or the problem, I'd go for a little walk and let your brain process in the background. And I think that often unsticks you, doesn't it?
I teach my students 5-minute meditation. It blows their mind to know that we're going to do that in class. But every Tuesday and Thursday, we count our breaths. And I say, look, you know, there's going to be a time when you're taking a test or whatever, and your brain is, you know, there's so much stress that you can't think anymore, cognitive load. That's when you do this. No one has to watch you, right? It's like you don't have to closing your eyes. You don't have to make a mudra. You just sit there and you do the mindfulness meditation, and it really works. And the kids report after they get over the bizarreness of doing meditation in school that it does help.
I'm glad that works. Bram, thank you so much for tonight. It's been an absolute pleasure having you. And as Bram said, if you all want more of a lab, we can put that on, and we'll pop that in the in the community hub, which is on replit.com/community, and click the big hub button. You'll see all the events and a big showcase across the top that we're having next. Before we finish today, I just want to make sure everyone knows what's happening this week, because it is the Tutorial Jam week. So we're having more education related events than normal. On Wednesday, we're having a read broadcast of Andy Colley's Prim workshop. Prim is a research-backed way of teaching programming and teaching the thinking skills behind it. So that's at the same time as tonight's session on Wednesday. That's a rebroadcast, so don't be worried if nobody's answering in the comments. It will just be played out. And on Friday, then, we had Tony Scullion on recently to talk about peer programming and group work. And that's a nice idea because Replit is full of multiplayer. So group projects are a great way of engaging people, especially people that have less understanding of programming up front, because it allows people to be supported and share the load. That's the same time again as Bram's session today, but that's on Friday, and that's a rewatch as well. And just one more push for the Tutorial Jam, because if you are a teacher or if you're not, we want you to submit one tutorial for the Tutorial Jam with prizes. First prize is $750. And what you have to do to be in with a chance of winning is enter one REPL, just one, with a tutorial in it. The new tutorial feature, the one we use for 100 days of code, is available to everyone now. You can have multiple pages of instruction and an overlaid video if you'd like. All you need to do to be on the chance of winning is publish it to the community with the hashtag TutorialJam2022 and submit it to the Tutorial Jam site. And I'll pop the link to that up on the screen now so you can find it. If I can find the button on my computer, there we go. But we'd love to see you submit something for the Tutorial Jam, especially if you are somebody that's done something interesting or exciting, and it's not just the standard, here's what a for loop looks like. We want all those creative coding ideas, flowcharting ideas, and all that good stuff to teach cool things in a REPL, because when everything's stored together and in one place, it does reduce the cognitive load. And that's what we've been talking about tonight, putting things together and making that cognitive load a bit easier. Right, well, that's us done, Bram, I think. Anything else you want to talk about before we go?
No, I hope people will do that exit ticket, and so I'll know how to schedule the follow-up where we take it out of the box and try it out. David, it's been great for you spending the whole time here. I didn't know that you would be staying with me the whole time, and your interaction was really helpful. So
that'd be fair, isn't it? Thank you very much. No, it's lovely to be part of it.
Really made the session count. Count Dracula.
I think your writers are better than mine. I need to get onto your writing team and get them onto 100 days with me. Bram, thank you so much. I'll pop the ending video in a second. But once again, if you've got any tutorials to submit to the Tutorial Jam, they must be in by Saturday. Thank you, everyone. Thank you.